All right, here we go, guys. So, you guys got this in class today. This is the section 5.5 note assignment. I'm going to try to go through this kind of quickly, so I'm not going to go through every single example that's on here, and we'll just concentrate on some of the big points in the packet. That way, we can keep the video kind of short, and I'll give you guys an opportunity to do some of the examples on here on your own, and then you guys can ask me questions in class tomorrow. Let's start off with this. This will be the book assignment. Okay. You guys will have some time to work on in this class. I do have an activity that I'm going to try to do with you guys tomorrow in class, or the next day that we have in class. So if you guys can get started on this independently, that would be ideal. And then you'll have a little bit of time to work on it during class, but we'll have something that we're going to do in class. So don't plan on having a bunch of time to work on it in class. All right, so 5.5 is all about introducing a new symbol to you guys, or introducing a new type of function to you, and that is the radical function, which looks something kind of like this. Most of you will know this as the square root. Okay, a square root is a very specific radical. There's lots of different radicals, all defined by the index value. So, in general, they're going to look like this. You have this thing that looks like a check mark. Okay, that is known as the radical sign. The value that is underneath the radical sign is known as the radicand. And then you have the index. The index is asking a really specific question. This actually isn't in the notes. I'm going to write this down here. So here's what this is asking. So if I have, for example, if I have x and I have a 3 here, this is asking what number multiplied by itself 3 times is equal to x. Multiplied by itself 3 times equals x. Okay, another way of thinking of this is if a cubed is equal to x, then the cube root of x would be equal to a. And we'll do some actual number examples of this here in a minute, and you guys can take a look at this. But the parts of a radical function or a radical expression, you have the radicand, which is the number underneath, the radical sign, which is the check mark looking thing, and then the index, which tells you how many times your answer will be multiplied by itself to get to x. All right, let's see here. Let's go to the next page here. Let's do a couple examples of this. All right. So if we go to the next example here. So if we go back to this question that I gave you guys here, what number multiplied by itself 3 times equals x, and we look at this first example here. This is asking, because the index is 3, this is asking what number multiplied by itself 3 times is equal to 27. Okay, the specific answer for this one is going to be equal to 3. Okay, let's talk about how I know that. I know that because I happen to know a bunch of the basic squares and the basic cubes just out of memory. This is worth it for you guys to put together. So if I do 1, 2, 3, 4, and 5 here, and then I'm going to do x squared, and I do x cubed over here. So I'm making just a little chart here. Okay, so, and this is going to be x over here. So 1 squared, that's 1 times 1 is just 1. 1 cubed is 1. And if I do 2, that'll be 4. 4 times 2 again, that gives me gives me 2 cubed. That'd be 4 times 2, which is 8. And do the same thing with 3. That'll be 3 squared is 9. 3 times 9 again is going to be 27. So on and so forth. So 4 squared will be 16. And then 5 squared will be equal to 25. And I'll let you guys figure out the last two values that go here. Okay, knowing some of your basic cubes is going to be cubes and squares is going to help you accelerate this. If you don't know how to do that, there is a way for you guys to get around it, and it goes back to something we call prime factorization, which I'm hoping is something you guys have been introduced to before. So prime factorization is when you take a number and you factor it as much as you possibly can. So we'll do an example of this. Let's do, we're actually going to do this one here. This is the 4th root of 16. So let me change colors here. All right, so if I'm going to do the 4th root, does that come up? Yes, good. Okay, so the 4th root of 16. I'm going to factor 16 as much as I can. Okay, so we'll write this here. 16 can be divided by 2. So if you guys have seen this before, a lot of people call this the tree. I'm going to divide this by 2. So if I divide this by 2, I'm going to get 8. I can divide 8 by 2, that'll give me 4. And I can divide 4 by 2 to get 2. So that's 1, 2, 3, 4 2's. So this is the same thing as the fourth root of 2 times 2 times 2 times 2. So the rule for this is that you can pull out a group from under the radical sign that is equal to whatever your index is. So if I have a 4 here, I can pull out a group of 4 from inside. So here's a group of 4 2's. And I can pull that to the outside of the radical sign as a single unit that I pulled out here. So I've got 4 2's here on the inside. I'm going to pull that to the outside of the radical as a single unit. So this will just be equal to 2 at the end. So 2, what I have left over would be the same thing as the fourth root of 1. The fourth root of 1 is always equal to 1. So this is just equal to 2 in the end. Let's do another one of these, just so you guys can see this here. Let's do 144 here. So we're going to do the square root of 144. So I'm going to do, let's do this right here. So I've got the square root of 144. I need to take the square, I need to factor out 144 because I don't know it off the top of, actually I do know it off the top of my head, but that's my point. Go ahead and factor out 144. 144 is even, so I'm going to cut that in half. I need a calculator for this, unfortunately. All right, so 2 divided by 144 is should be 72, I believe. 144 divided by 2 is 72. All right. 72 I can break in half. That's going to be 36. 36 I can break in half. That'll be 2 and 18. I can break 18 in half. That'll give me 2 and 9. Okay, and 9 I can break into 3 and 3. So 144 is really the same thing as the square root of 1, 2, 3, 4 2's. So I have 2 times 2 times 2 times 2, and then a 3 and a 3 here. So I'm going to multiply by 3 times 3. Okay, all right. If you ever don't have an index written here, if it's ever just blank, it's a square root, and square roots are specifically an index of 2. So there's really an index of 2 on any square root that you guys are going to see. So let me see if I can clean that up a little bit. Okay, so that's 2 right there. So this means that I can pull out groups of 2. So I'm going to identify groups of 2. Here's a group of 2. Here's a group of 2. Here's a group of 2. Each of these comes to the outside of the radical sign as a single unit of whatever the pair was. So that's going to be a single 2, that's a single 2, that's another single 2, and that's a single 3. So that's going to be equal to 4 times 3, which is equal to 12. What this means is that 12 squared is equal to 144. Okay? All right. Go back there, show that again. You guys can pause the video if you need to look at it. Okay? Rotate that really quick if you need to take a look. All right. I'm going to go ahead and have you guys do the rest of these. So pause the video for a minute and run through the rest of these and try to figure them out. Try to find, factor out negative 32, factor out 16. Well, actually, we did the 16 one. Factor out these other ones and see what you guys can do. Remember, try to group by pairs. I'll help you guys out here. This has got an index of 2, and this has got an index of 2, if that'll help you guys with your grouping. Stop the video. Try to finish the last few of those. Okay? All right. Now that you guys are done with that, let's take a look at negative roots. So we cannot take the square root of a negative. So the thing you're going to find here is that square roots are really undoing squares. So whenever I square something, the thing is if I square a negative, so if I have like negative 2 squared, a negative times a negative is always a positive, so I always get a positive number out of it. This means that whenever you take the square root, a square root undoes a square, which means there's no answer for this. There's no answer for the square root of a negative number. Okay? So even roots can never be negative. So there's really a 2 here. If it had been a 4 or a 6 or so on and so forth, that means we have an even number of things multiplied together. An even number of negative things multiplied together is still positive. Okay? So even roots can never be negative. The only time that we can take roots of negative numbers is the index must be odd. Index must be odd. Okay? All right, let's go to the next page now. All right, finding the nth root. So this one here, let's see here. We'll just run through these really quick here. This one's going to have no answer. This one's going to have no answer. So let's try the other ones here. The fourth root, so what number multiplied by itself 4 times is equal to 1? That's just 1. So this one will be equal to -1. This one here, I'm going to make you guys do this one. What I want you to do is I want you to take -64 and I want you to factor it out. Okay, so we're going to do 64, factor it out, and you're just going to pull out the negative at the end because it's odd, so we can pull the negative out at some point. So you guys can pull a negative out of it and then factor 64 and pull out groups of 3 and see what answer you get for that one. Okay. Roots of monomials. This is really the meat of this section. This is really what we're getting at. Everything that we do up to this point, it's grouping numbers. We're doing prime factorization, things of that nature. Ultimately, what we want to be able to do, though, is we want to be able to simplify these things that don't really have a numerical answer to them. Things like square root of -144, or if we switch back here, the square root of 144, the fifth root of -32. You can stuff those into a calculator. You can get a decimal approximation or get the perfect answer for it and stuff using technology. These you cannot do using technology. So we have to do these the hard way. Okay. I'm going to give you some properties here. We will go over the properties more later, but there is one that I want you guys to have early on, and that is square roots, like exponents, you can break them up over multiplication. So this is really the same thing as the square root of 16 times the square root of x to the 4th times the square root of y to the 10th. Okay, so I can break it up like that, and then I can solve the individual ones. Square root of 16, 16 is just 4 squared, so this will be equal to 4. Okay, x to the 4th is x times x times x times x. There's a 2 right here, so here's a group of 2, so I can pull out 2 groups of 2, so I'm going to have an x squared on the outside. And then y to the 10th, that's y to the 10th, there's 5 pairs in y to the 10th, because there's also a 2 here, so there's 5 pairs in y to the 10th, so this is really going to be a y to the 5th when I pull it out. If you guys didn't follow that, actually write it out as y times y times y times y 10 times and find all the pairings and then bring them out of the radical sign, and you'll end up with y to the 5th. Okay, so that's the answer you're shooting for there. All right. Dividing exponents. This step is actually done early because you guys need the fractional exponent rule in order to use step 2, which is what we're going to do next. All right. Some more examples here. Finding roots. Go ahead and work these out. If you guys have questions about these, ask me about it in class. We'll go over them then. This is the one that I want you guys to know. This is what we call the fractional exponent rule. So all a radical really is a fractional exponent. It's when we have a fraction in the exponent position. If you remember from all of our FOIL problems and our exponential problems that we've done thus far, every time we had an exponent, it was a whole number. Well, now we have fractions for those numbers. Okay, so let's talk about what this is like. So we're going to rewrite these as roots. Whatever is in the denominator of the fraction is the index of our radical. So 16 to the 1/2 power is really the same thing as the second root, or the square root, of 16. The 1/3 power is going to be the cube root. So we have the cube root of 27 for that one. Okay, and you guys will do that here. So finding the nth root, I'm going to ask you guys to go ahead and work through all of these. If you guys get stuck, ask me about them. We can take a look specifically at 15 and 8 and 16 during class, and we'll try to sort all of those out. Okay, something you guys can remember here. This is a really, really powerful rule when you guys are working with these, because this allows you to divide things down using the exponent rules. So, for example, if we look at 15 and 16 here, you may remember that we have a rule that says when you have an exponent raised to an exponent, we multiply the exponents together. Well, if I've got x to the 12th here multiplied by 1/4, 12 times 1/4 is just 12 divided by 4. So this exponent here is really just 3. So we're really just going to have x to the 3rd when we do this one here. And then we have the 4th root of 81, so on and so forth. And then I'll let you guys figure out the rest of them. All right. You guys owe me an assignment tomorrow. I would like to see these 3 warm-ups. You will turn these 3 problems into me at the beginning of class. This is not going to be extra credit. There will actually be an assignment attached to this. So you must turn in these 3 problems and then go ahead and get started on the book assignment. All right. I'll see you guys tomorrow in class.